All right, Advent of Code 2022, day 3. I'm a little late because I went to dinner and got back super late, so let's jump right in. Rucksack reorganization. Each rucksack has 2 large compartments. All the items of a given type are meant to go in exactly one of the 2 compartments. The elf that did the packing failed. To follow this rule for one item, the elves have made a list of all the items. Every item type is identified by single, lowercase, or uppercase. So let's go ahead and set up a day here, 3. That's the tests. Whoopsie daisies. And let's go ahead and run this real quick, see what kind of data we've got. Data 3. Here's some sample data. Okay, quite a few numbers in a single line. The first rucksack is this, which means its first compartment contains the items of that. Where does that get us in here? All the way to R. Then there's an H. What splits these? Every item type is identified by single, lowercase, or uppercase. A is different from A, uppercase. List of items given all on a single line. Okay, so a line is a rucksack. A given rucksack always has the same number of items in each of its 2 compartments. Something like that. So the first half of the characters represent items in the first compartment, while the second half represent items in the second compartment. Okay, so that must mean that of this, right, so if we printed the length, these should all be odd. Oh, they're all even. That doesn't make any sense. Well, the second compartment contains this. The only item type that appears in both compartments is this. So if we divided it by 2, yeah, that's super interesting. The R here is there. So we've got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First compartment, that doesn't add up based on what they just said. A given rucksack always has the same number of items on each of its 2 compartments. So the first half of the characters represents items in the first, while the second half represents items in the second. For example, suppose you have the following. The second rucksack's compartments contains this, and this, the only item between them. Let's go for the smallest one, which is this TT. The third, yeah. Contains all the way to this capital V. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8. Oh. It splits it perfectly by 2. Okay, so this is going to be compartment size. It's going to equal the length of that. And so if we wanted compartment 1, we're going to have the item up until compartment size. And compartment 2, we're going to have everything like that, right? And if we printed that out, slice indices must be integers. So we're getting the whole thing, and we just want the first few elements. So that would be 3. You're taking the length, you're dividing it by 2. So why doesn't this work? Because it wants an integer. Because we're never technically going to have, yeah, there's never going to be floats, and so we can do that, and we do get what they suggested here. Okay, perfect. So now we've got compartments 1 and 2, and now we want to look at what is the only item type that appears in both compartments. Okay, so now we need to say, we basically want to get a set of items that appear in both. So if we wanted a set, we basically want to find that P is the thing that happens in both of these. We could iterate over it, but that's too slow. So we want find unique values into lists Python. Yeah, something like this. Yeah, this is kind of what I was thinking. Yep, there we go. We want this to be a set. And then we can say appear in both is going to equal this one plus this one. And in theory, this should get us, we can't add sets together. Why not? Oh, and do we? Because we want to see what's in both. Perfect. So we've got that. And so if we go back to the prompt here, then we have to give it some points, I believe. Yep, we're getting close. In the above example, the priorities are like this. And so then we sum the total of those up. So we're going to call this common, and we're going to append appears in both here. At the very end, we're going to print out common. It's going to give us the list of items. Ooh, I don't like that at all. Because it's a set. Gross. Yikes. A set of 1. I don't think it works like oops. I don't think it works that way. Can we do it like that? Nope. I don't think I want this either. This will just put them into lists, which isn't ideal. Although what we could do at that point is plot a single element. What? I mean, yeah, it's gross. For time's sake, single, we could pull out the single. Okay, so now we've got that in strings, which is what we want. It's ugly, but it works for now. Okay, so now we need to assign these, get values, get indexes of alphabet. I think this is built in. Yep. This is built into Python. I remember this last year, there was a problem that had something very similar. Now this is only going to work for half of what we want, right? The first set. So if we said for character in common, get the string of the character, and the points is going to equal 0, and so we're going to points plus equals this, and this still isn't correct here. String points, and then we can print the points, and this doesn't account for all of the uppercase ones. String has no attribute lowercase. Oh, what can we do? Ooh, tricky. Substring not found because we have an uppercase, right? Let's just to see if this works, let's cast it to lower. 99. Okay, cool. So check if string uppercase Python. We've got is upper. My problem with coding is that I code in 7 languages for my job, and so I very quickly mix all of the syntax up and I don't know what is what, so it's tricky. If is upper, is that even a thing? Is this even Python? It is. Oh, is upper. I don't think that's a built-in. Yeah, why is it throwing an error? Oh, because it's an if statement. Okay, if it's uppercase, we're gonna pass for now. If else, we're gonna do the lowercase. Does this have an uppercase equivalent? I hope uppercase, right? Right? 73. And if we look at the prompt again, 157. That is definitely not right. Oh, because, okay, right. Because the uppercase A through Z's are worth more because they continue. Right, so right here, what we need is the uppercases is like, there's a part in here that really described it. Oh, here it is. Lowercase is 1 through 25. This is 27 through 52. So everything is going to be 26 plus its original value, right? Is upper plus 26. Sorry. Oh, we don't even assign points plus equals. We get the 99, and if we put that back, we get the 151. That's not correct. Do we have... I mean, we're calculating all that correctly, so that's good. PL, this is capital PL, and a lowercase p. Okay, so we've got all the right input. So something with this isn't quite right. Right, so if we had upper, index of 0. Index of 0, so +1, +1, 157. If we swap this to input, we should get our answer. 7999, that's too many 9s in there. Cool, 1 gold star. Part 2. For safety, the elves divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if the group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying other item. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All the badges need to be pulled out of the rucksack so the new blah, 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 write down, blah, 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 blah. Okay. Common between all 3 elves in each group. Every set of 3 lines in your last single, but each group. And the second, in the first group, every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, and the second group is this. In the first group, the only item that appears in all 3 of these is that. So it's the same concept, just split up differently. Oh, wow. So we can do if the index is divisible, what is that stupid operator? I'm going to cheat. No algorithms. Silly me for getting this. Algorithms, sorting, search, nope. Sequences, FizzBuzz. It's just I had it wrong, or I had it close. If an index is divisible by 3, with a remainder of 0. Does that work? 0, 1, 2. Start at 1. If it's divisible by 3, then we do this, right? No, that doesn't work because we need to group. I think it's close, or what I have in my brain is close. We're going to go to every third one, and we're going to go backwards 2 and grab all of them. See, for part 2, we don't even need this column size probably because it's per line at that point. Actually, we're going to put this back because this is good thinking. I'm going to grab all of this. That's part 1. Right, we're going to open up a whole second one, actually, because the logic is not going to be shared completely. Get answer 2. We can get rid of some of these extra prints in here. Okay, so get answer to 2. We're going to do the same concept. We can get rid of this, this, and unindent this. And okay, for part 2 here, if it's 2, we no longer need the column size. We no longer even need this, but what we do need is rucksacks is going to equal maybe we can do this. Rucksacks is going to equal an empty list. We're going to append data of the current index. We're also going to append data of the index -1 and -2, which should give us the last 3 sets. I don't love it, but that's what we're doing. And then here we're going to say rucksacks of 0 and rucksacks of 1 and rucksacks of 2. Appears in 3 for item single. Print common, right? Or we got nothing because we're not running this. 2. It's not returning anything, so it's going to spit out none. String and string. Something or other. Unsupported operand. Yeah, what were we comparing up here? These were sets. Oh, yeah. I guess what we could do is make each of these individually a set. Set, maybe. Ooh, okay. And we're doing it for all of them, so I actually just need it to be there. In the first group, the only item in all the rucksacks is lowercase r. We got that. In the second group, it's a Z, but it's capital I. Well, these could be out of order. For character in common, if the character, and then we do the thing, and we're not printing out points to make sure that this is what we need. List index out of range. Common.add, this is out of range. Can we print this and see what's up with that? We've got Z. We're not resetting something correctly. Let's just make sure. Okay, we've got 3 rucksacks. Oh, let's go back to sample real fast, so I know we're looking at the right data. That is not correct. This would be 3. This would be 2. This would be 1. Let's break. And let's print out the single line item. I mean, that's included. And that's the last one, which is correct. If we did, oops, I guess we need this. Is this getting us the very last one? I think. Oh, how interesting. That's giving us the same one. That's giving us that. That's giving us the first. Do we need -1, -2, -3 maybe? Getting the sum is 70. Input, let's just YOLO. 2545. Woo! Okay, that's day 3. So let's go ahead and look at what we actually did here. There's quite a bit. We needed to find the rucksacks. Every line was a rucksack. Each were split into 2 compartments for part 1. All the different characters' amount of points, if you will. Every item or every character was an item in each rucksack. So we wanted to find what was common between the two sets of one rucksack. So we got the size and split it in half, because then we could have two different sets of the rucksack, the left side and the right side, basically, because it's split right down the middle. Then we wanted to see what appeared in both, so we set it to a set and said, hey, what is in both of these? Or what comes out of this? Then we had to do some dumb parsing because it put it in a set, so we wanted to put it back into a list. I'm curious. Get a single element from set. Next iter my set none. We could clean this up a little bit, I think, by doing appear in both true and get rid of this one, I assume. We got too many print statements in here. Let's get rid of these guys. And we'll return points instead. And here we'll return points. And we still got a print somewhere in here. Where is it? We've got answers 1 and 2 printing. Oh, there it is. Don't need that rucksack. Okay, so there we go. We've cleaned this up a little bit. That is still the correct answer, so we're going to use this as well. I'm going to try and remember this and look into this a bit more in the future. It's quite a bit more elegant than appearance 3, my solution. There, let's make sure we get the same answer. We do. Okay, that's a little better. So we basically want to get that element out. Then what we're doing for every character in the common set, if it's uppercase, we want to... All right, let's name these. And then number of characters in alphabet is going to equal 26, right? Because we have to offset these. If it's uppercase, we want to go find the index of that character in the alphabet. We're going to add an offset, right? Because everything starts at 0. And then the number of characters in the alphabet, because per the prompt, a capital letter is, let's see, right here. Capital letters start at 27, go through 52. So we needed to add the number of characters that came before that, which was 26. If it is not uppercase, then we want to just get the offset via the strings package in Python, or string, excuse me. Then we return the points. That's it. For part 2, a little different. Sets of 3 rucksacks make a group. And then what's common in a group. And then it wants the total number of points. We don't even need these items. We're not using them here. I guess it's just this one. So for this one, we needed something a little different. There's probably better ways to do this too, but what I thought on the fly was that if we enumerate over this and we use the index and we start at 1, we can actually pick what sections that we're going to use. So for instance, we're going to set up a list here of rucksacks because we have groups of 3, right? So we need a list of 3 essentially. And if the current index is divisible by 3, we're going to start building our list. That ensures that every third item that comes up, we're going to build a new list for. I don't have an answer why this needs to be a -1. Oh, same concept to offset back the index, right? Because we're starting at 1, index starts at 1, which helps this if index bit, but what it doesn't do is help us look it up via this method, so we have to re-offset it by 1. Normally this would have been index -1, -2, which is why I had a little bit of a struggle, but because we flipped it here, it was off a little bit. So anyway, we grab the 3 that we need, we do the same exact concept as before. Hey, what of these 3 rucksacks now are the same across all of them? We append that to our set of commons, and then the same concept as before. We could clean this up a tiny bit if we really wanted to. We could say Offset, wow. Offset is that. Number of characters for the alphabet is this. We do that. And then, last but not least, of course, we can punch in our answers, make sure that it checks them correctly. And if it does, we're good to go. We cannot unpack a non-iterative int object, so we probably just need to tweak something up here. Yep, I basically forgot to put it there. There you go. 2022, day 3, challenge complete. If you enjoyed this, leave a like, subscribe, and I will see you tomorrow for day 4.